FMT package, format package, and we can look at that real quick since we're on the topic of math. And there's all kinds of stuff in here. There is a, it's not really a round. There's a floor and a ceiling. So this is one of those things where like there's been this use debate, why is there not a round function? And it turns out that there's lots of ways to round numbers. There's actually different ways to do it, so anyway. So the trick is you add +5 and then take the floor, and that's the same, or something like that.
Yeah, +5 and take the
floor. The floor is like the, yeah. But yeah, there's a bunch of other math. You can do trigonometry, you can do all kinds of stuff in the math package. There's also some constants in here, and look, here's our friend pi. With a lot of digits. It's pretty fun.
What's pi?
I forget what phi is. I guess none of us in here are math people.
This is the table.
I've never seen phi.
Okay. So back to types. Now we'll look at strings. Strings are the other big thing we use a lot. Okay, so a string is just a series of characters. And strings in Go use an encoding called UTF-8. I showed you a little bit of that. UTF-8 is an interesting encoding. So, because we speak English, we're at we have an advantage because most of the text on a computer is in English. And we use ASCII. ASCII is a 7-bit character set, okay? And so UTF-8 is those 7 bits, that same 7-bit character set, which is 128 letters, right? And then it also has, you can have, for everything else, it is multiple bytes. So it can be 1 byte, or it could be 2 bytes for a character, or 3 bytes for a character, or 4 bytes for a character. So things that are written in Chinese are going to be probably 4 bytes for each character, okay? Because it's a multi-byte character encoding. The nice thing about UTF-8 is it's backwards compatible with ASCII, so ASCII characters all look the same. So that's an advantage. And the reason why Go uses UTF-8, which is often the reason why Go does all the things it does, is that Rob Pike was partially inventor of UTF-8. So of course it would use UTF-8. So, and you'll see that again and again in Go, where they made a decision, well, that's how they did it. So that's why they did it the way they did it. So, but anyway, strings are a series of characters. And in general, you don't have to worry too much about the UTF-8. It turns out that for most of what we do with strings, we're not actually that interested in things that will actually impact the UTF-8 stuff, okay? So, the basic things you can do with strings is you can create them. We saw that at var x equal, and use double quotes to create strings, okay? Now, we can also use backticks. So, backtick is the tilde, the character by the 1 up there. And this is the same as using the double quotes. The neat thing about backticks is it can be multiple lines, right? So
You can't do double quotes for multiple lines.
no, the double quotes is only 1 line. So that should do what I think it will. Yep. Notice it included the tab because it includes everything inside the backtick, like a raw string. So the other thing about strings is strings support escape sequences. So if we wanted to do what we just did, we could do it like this. Use a /n, and that's going to replace that character with a new line. Okay, follow? And then if we wanted to use a tab, we could either put a tab in directly or use /t. And you get the idea. The full description of all those things, once again, is in the spec. It basically is the same as C and Java and C#, and everybody basically does it the same way. But you can see the list of all the things you can do. So the neat thing about the UTF-8 is you can write strings in Chinese or whatever. You don't have to stick to English. But anyway. Right, so strings have a length, okay? In C, strings always end with a null byte. But in Go, a string has a length. It has a definite size, okay? So we can get the length of a string by using the function len, okay? right? And that says 18. 18 characters. So this isn't 18 bytes, I should say. It isn't necessarily the number of characters, because like I said, some of the characters are more than 1 byte. But this is the length of the bytes. Okay? And so if you were to count these, you know, however many there are, it's supposed to be 18. -2 because the /n gets converted into 1 character, and it's 2 in the source. So, but that's the length. So the length, to get the length of a string, you use len. When we see arrays and slices, len's the same thing. Okay. So this length function is a built-in function that gives you the length of things you give.
We need a single thing, a single byte.
Yeah, so the /n is 2 bytes in here. It's 1 byte when you run it, because it converts the /n into a new line. Okay. So a new line on a computer is a character that when you render it, makes it go to the next line. In Windows, it's typical instead of /n, it's /r/n, just to be confusing. So, which is a line feed, which apparently goes back to the days of typewriters, and for some reason we still care about all that. Teletypes and printers and yeah. So, okay. Now, other things you can do with strings, you can concatenate them. So, when you use plus with numbers, you're doing addition. When you use plus with strings, you're putting them together. So, if I have a string, you know, hello world, and then I want to add test to it, I can do this. Okay. And what that does is it takes 2 strings, and it creates a new string, a 3rd string, with them put together. Everybody follow? That's concatenation. Okay. So the plus means different things depending on what is on both sides of the plus. Okay. So if we print this, we should see hello world plus. And there's our hello world plus. Okay. You can't add a number to a string. Okay. Cannot convert hello world to type int. Invalid operation, mismatch type string int. Okay, that's the strongly typed, like I was saying before. Okay.
Now, if I wanted the number to be a text,
Good question. You would wrap it in quotes.
you wrap it as a string. define it
Exactly.
That way.
Yeah. Now, if you had a number, remember how we were like scanning numbers from the user? Let's say we had that. So. And now we can't just wrap it in quotes, right? Because if I wrap this in quotes, I mean, that's just, well, it will just put X, the literal X. It won't put 5. So how do I do that, right? Like, how am I going to make that work? Does anybody know? Just offhand.
I was just venture a guess of strx, str.x or something like that. Converted to a string. It must be
Yeah.
some command.
So it turns out there's a library that can let you do this called strcond. S-T-R-C-O-N-D. I missed the T. I2A.
Oh, wow. It's bigger than I expected.
Right? You can do it that way. That's like super hard to remember. And this is once again, if you know C, you're like, oh yeah, IDA, of course. But everyone else is like, what the heck does that mean? You could use the format library, and you can say sprint. String print. Sprint.
You stuff put it in quotes.
Yeah, not in quotes, sorry. Forgot.
Oh, okay.
Yeah, you're right. And now it'll do what we want it to do. So that converts our number into a string. That actually converts anything into a string. It could be a floating point, it could be anything. You know. Same thing. Okay, so that's how you do the conversions, but just wanted to remind you that the plus here depends on the sides, what's on the sides of it, and they have to be the same. That's all I'm saying. And that also means they have to be the same if they're float6 for an int. You have to convert one to the other. So let's look at that example, because the conversion there is a little different. Right? So if I have x and y, and I want to convert, and I want to print x plus y, right? It's going to say that doesn't work, mismatch types. So the way you can convert them is you have to do it explicitly. and you take the type, and then you put parentheses, and then you do it that way, okay? And that takes y, which is in it, converts it to a float 64. Okay? So you use the type as a function to do the conversion.
And if you turn float 64 into an int,
Yeah, you could do the same way, but with the other argument, the same thing. And what it's going to do is going to truncate the decimal places. So actually, if we want to see that,
will it run first?
so it took out the 0.54, just gets rid of it. Sorry, what do you mean round first?
If it was like 0.9, would it go to 6
Ah,
instead?
Yeah, it does not round in floors. You didn't lose it, it's gone. So if you want to round, like I said, you have to do the add 0.5, take the floor, then convert it to an int. And that will give you an integer that was rounded from it. So int of,
You need to force, it's automatically forced because of it.
something like that. So yes, that is a little tedious.
You need to force, it's automatically forced because of the conversion.
No, well, but here I'm trying to round.
Yeah, you're still going to round though, but since the int conversion is already truncating, you don't need the floor technically. So
Oh, that's a good point, probably not.
Is there a not round?
No, there probably should be one, but they never added it.
Make use of that first.
Like I said, there's actually different ways to round numbers. And it was funny reading their bug report. They're like, there's lots of ways. I'm like, I didn't know there were. But so sometimes people, because the problem with the normal way people round numbers is it by going on 0.5, it's like, it's not fair. It rounds up too often or whatever, right? It should, and so sometimes they'll look at the second digit after the 5, and if it's even, it'll go one way, odd, it'll go the other way. And so there's all these different rules for rounding it. Okay, so we saw string concatenation. We saw that types have to be the same. We can't do plus unless they're both the same. So here's examples how length. The other thing you can do with a string, so is we can use this subscript operator, right? Okay, so in brackets, we put a number. And that gets the, yeah, it's the third character now, because it starts at 0. Which takes some getting used to, but turns out to be, in general, more convenient. So when you see x sub 2, you know, it's x, the third character. So we should expect that to be L. Oh, but of course,
Gives you the value.
the number, which I'm sure you know. But, so this returns a character. It returns a byte. Okay, a uint 8, which is a byte. Oh, I didn't. Byte is a synonym for uint 8. Okay, so
One is 8 bits.
that's because bytes are super common. Okay, the building blocks of lots of data structures. So a byte is an 8-bit integer.
It's a synonym for what? I'm sorry.
Uint 8, an unsigned integer.
So each symbol is 1 byte or 1 bit.
In general, each letter is 1 byte. Okay, so x2 L is the number 102, which is a single byte. Now, if I were using Chinese, it would be more than 1 byte for each letter. But usually it's 1 byte. But that's the subscript operator. So you can get the whatever character of a string that way. So actually, this is interesting. If you're from C, what does this do? This is probably going to be a problem, right? Because the string isn't 30 characters long. So what am I going to return when I run this string? No, you get a pin.
Next out of rank.
Go is safe. It doesn't let you do bad things like this. So, unlike C, which would just exactly like you say, just go grab some bit of library, return it to you. This is like, no, you can't do that. Index at a range. So the indexing here is enforced. This is a little different than we saw before. So before we were seeing compile time errors, right? We were seeing, I try to compile it, it doesn't let me. This, I can compile it just fine. But when I try to run it, I get this error. So this is a runtime error, okay? The others were compile time errors. So there are some runtime errors you can get. And this is an example where you can
Yeah, because that compiles fine. It's like, okay, I'll look for something at that
yeah.
location, but at runtime, when it looks at that location, it's like there's nothing here.
Yeah. So,
A bit more emotion though, it's panicking.
yeah, panic. Yeah, so in other languages, you have exceptions and they're thrown. That's like the verbiage. In Go, you have panics, like which is like, yeah. Because in general, Go wants you to return errors and not throw them, so that you have to deal with them. You have to do something with them. Because a tendency when you have exceptions is just to ignore them. And then when you launch your code to production, you get exceptions. And you didn't account for them, you didn't write code to do anything about it. You know, oh, I just ran out of space or whatever, and it just breaks. So this is like, we only panic for things that are like really bad. And so panics usually indicate that me as a programmer, I screwed up, right? This isn't indicating that some weird thing happened on my computer. This is indicating that I should be checking the length of my string. So in general, when you see panics, it means you've probably made a mistake. Okay. So a few other things. I think we know this. The space is a character, right? It's like number 20 or something. No, that's a hex. 32. So it's a character. Remember that. It's part of the string. They index from 0. We saw that. And then we saw concatenation, the same as addition. Any questions about strings?
What do you mean index 32 or something? You're saying it's like each character has like its own index.
So H is 0, E is 1.
So what's like that?
That would include upper and lowercase, I'm guessing.
So the space character, like when you hit space, that is a byte, and the number is 32. And yes, uppercase and lowercase letters are different characters. And they're like all in that table. You can look up ASCII or look up Unicode, and it'll list in a big, huge table all the possible numbers, and you can see all the possible ones in there. Any other question about strings?
Does Go care about the character term, \0?
You mean a null byte? I think you're allowed to use a null byte. And this would be a difference between, I don't want to print, yeah. No, you can't use /0.
But does it represent it even if it's not there, like C does?
It doesn't, I don't think it ends with a null byte, because it knows the length of the string. So it doesn't need a null byte.
So is a string an array?
Yes.
I've also seen slice of bytes. That's something further on.
That's a little different. When we cover slices, we'll look at that. And then the final thing are Booleans. Does everybody know what a Boolean is? Anybody not know what a Boolean is? True or false? 1 to 0. So just know in Go you have Booleans. You have these basic operators. 2 ampersands means and. 2 pipes means or. Exclamation point means not. You use these a lot, actually, with if statements. So they're useful to remember. They do what you expect them to do. True and true is true, true and false is false, true or true is true, true or false is true, etc. Basic logic, right? You can have the table to see what they mean. So, strings, numbers, Booleans are the basic types in Go, okay? And then there are other things that build out of them. So, those are the basic ones though. So, you asked this question already about the base 10 thing. So the question being, what's the largest 8-digit number? Anyway, we covered all that. We've done arithmetic. we've done that. So I think we've answered all these problems. So these are the basic types. And I think the example we saw before used them, right? So when we did our program over here, we were using types even though we didn't necessarily know what they were. Okay. Okay.
What would be your answer, go ahead.
No, no.
What would be your answer to that question? How are integers stored on a computer?
They're stored as binary digits, right?
Okay.
Zeros and ones.
I didn't know how in depth you wanted that answer to go.
Yeah, and
Should I look some more stuff up?
we could do that, and maybe that's worthwhile. And I thought about doing that, of describing more in depth about what this is actually doing. I mean, if you guys are interested in that. Like in terms of memory and stuff. So maybe that's worth looking at. Maybe we should take a short break if people need to go back and stuff.